only the way meteorologists look at it. It would be the map that you see when you look at your weather forecast every night. In your weather forecast, you're barely going to see that. What you're going to see is a zone of high pressure is moving east, and a zone of low pressure is moving west. There's a warm front that's moving to our area, and there's a cold front that's moving out of our area. There's a mass of air going slowly. There's a mass of air going fast. It's a map of intensities, highs and lows of pressure, hots and colds of temperature that is constantly mobile. In a good meteorological show, they will show to you animated because they will be moving. And it is those differences in intensity that cause the appearance of hurricanes, of thunderstorms, of clouds, of every single meteorological entity. If these differences disappeared, if all of a sudden the whole planet was equally warm, if all of a sudden the whole planet was at the same pressure, if all of a sudden all the air on Earth was at the same speed, there would not be any clouds, there would not be any hurricanes, there would not be anything. Everything would look like we're living in London. Everything is gray, homogeneously gray. And it is because of these differences that these things happen. Let me give you perhaps an easier example to understand. You take a box that is divided into two parts by a very well-sealed division. Everything is nicely sealed. And you inject hot air in one of the two sides of the box and cold air in another side of the box. All of a sudden you have an intensive difference, hot and cold. Now, that intensive difference contains energy. For as long as the difference exists, there's energy to be exploited there. If you open a little door in the subdivision that's keeping the two chambers isolated, there will be a spontaneous flow from the cold side, from the hot side to the cold side, just spontaneously. You can in fact tap into that flow to drive a little electric motor because the flow will be spontaneous. That principle is the principle of the steam engine. When the first steam engines that, of course, were the machines that caused the Industrial Revolution, or one of the main components of the Industrial Revolution in England, were invented, you had on one side a boiler, which of course a worker was feeding coal into to keep it hot. And on the other hand, you had something that needed to be very cold, which is typically just earth itself. Earth, particularly underneath the soil, the topsoil is very, very cold, so you can use that as your cold side. You have now an intensive difference. When you connected them via a wire or via a tube, you automatically generated a flow that went from the hot side to the cold side. If you then introduced in the middle of that flow a machine with two pistons, you automatically were able to get from that flow energy to draw the two pistons, and then the two pistons of the steam engine could then drive a hammer to do some industrial activity that normally would have taken a human being hammering the thing. The steam engine replaced workers in certain activities because it was fed by intensive differences. So intensive differences are very important for us because if we're going to be talking about processes that produce entities without essences, we need to know what is the fuel for that process. Intensive thinking is a type of thinking that forces you to think what is fueling that process. The process of evolution is fueled by sunlight, by the differences between sunlight on one side of the earth and not on the other earth. And of course by plants that, through photosynthesis, get energy out of that sunlight, the herbivores that eat the plants, carnivores that eat the herbivores. If there were no food chains like that, there would not be evolution. We would still be at the level of the original bacteria that were doing fermentation of sugar in order to get their energy. They were still dealing with intensive differences, but not the super powerful intensive differences that have driven evolution. And of course, without intensive differences, we wouldn't have human industry, because human industry is driven by temperature differences, pressure differences, and so on. But of course also, the planet itself, at least the atmosphere, hydrosphere, is driven by this interplay of intensities. When Deleuze talks about a body without organs, that's a very famous Deleuzian concept, the body without organs. He took it from an artist, Antonin Artaud, who was the inventor of the theory of cruelty. He invented the word, but Deleuze adopts that word because he wants to say, look, this planet is a body. It's a body of water and air that's bounded. You know, you can look at it from outer space and you look, hey, look, that's that ball. And there's an empty space around it. So it's a body of water and air that's bounded and is animated by mobile intensities. That's the definition of a body without organs. A body, a bounded body of water and air in this particular case, is animated by mobile high pressures, mobile low pressures, mobile hot fronts, mobile cold fronts, mobile masses of air moving fast, mobile masses of air moving slow. As long as the differences are alive, the body is alive. It can produce processes. It can spawn hurricanes. It can spawn tornadoes. It can spawn thunderstorms. It can give birth to things. It's without organs because it doesn't have DNA. It's not like a plant. It's not like a bacterium. It's not like the ones that we were examining in the previous population thinking. It doesn't have DNA. It's not tied up to a species. It's in fact much freer than a species. Because it has not been reproductively isolated, there's nothing to reproductively isolate. And so he calls it a body without organs. Now I'm giving you this image because the most important thing about, let me put it this way differently. The largest obstacle to understanding Deleuze is his terminology. He talks like a hippie, right? He's from the 60s after all. In the 60s, everything went. You know, you can just talk about this thing. And Deleuze is not the type of guy that just uses a funky terminology and then sticks to the funky terminology like Derrida with deconstruction. No, that's too easy. He has to change terminology every chapter. So you are going through one chapter, and then you go into the next chapter, and then it's like completely different terminology. And you go to the next chapter, it's like, oh, but, you know. And that is an obstacle to understanding what he's saying, even though he loved it and it was part of his own writing process and his own joy of writing was partly inventing all these terms and sounding like a psychotic lexicographer. And you're not going to take that joy from him. After all, that's what gave him joy. Hey, let's respect him. But it has become an obstacle to understanding his materialism because a lot of people think that he's just fooling around with words. I mean, who in his right mind would use all those different words? The concept of the body without organs is very badly understood because it is never tied up to a specific meaning. So if we tie it up to a specific meaning, it is much easier to understand. This body doesn't have any organs and yet is animated by mobile intensities.
So you wouldn't see like ice caps or deserts, you know, if you're in the map kind of metaphor as being organs that influence how the processes occur?
A little bit, yeah, that's a good point. In mountains, also, you know, right now I'm isolating the two sides, but in reality, these two things are in the same reality. And the Rocky Mountains over here do affect the weather because they make certain clouds, they present barriers to clouds, they present barriers to airflow, they cause rain on one side of the mountain, but not on the other side of the mountain. And yes, they are. Those mountain ranges, those deserts, those coastlines do act as a little bit like organs, giving the planet a little bit more of a kind of territorialized or stratified way. But even in this case, just take a sip there. Let's move on to this case again.